So there is another question here. They are saying we should find the eigenvalues of A given that A equals 2, 1, 1, 2. So to find the eigenvalue, we'll start with a formula. So I will say A minus lambda identity equals 0. Now that we have this implies that where there is A, we are putting this matrix. So we'll say we have matrix 2, then we have 1, 1, then we have 2. Minus lambda, open. I is the identity of this matrix. So we have 1, 0, 0, 1. Everything should be equal to 0. Now that we have this, we multiply the lambda to the identity. So when we multiply, we have here we still have the matrix 2, 1, 1, then 2. We'll say minus. We have lambda, 0, 0, lambda like that. Then is equals to 0. Since my board there is no enough space, so I'll clear the top part and continue. So if you've not written what is up there, you will write. You pause and write. So there I'll say, now I'll subtract this matrix and this matrix. So when I subtract, here is 2 minus lambda, 1 minus 0. So I'm having something like this. Our 2 minus lambda, 1 again, 1, 2 minus lambda, like this equals 0. Then when we reach at that level, what we'll do is we'll solve for the determinant. These lines they are standing, this matrix we should find the determinant. So here we'll say this times this, so we'll say 2 minus lambda times 2 minus lambda minus 1 times 1, which is 1, is equals to 0. Then from there we multiply 2 times 2 will get 4. 2 times negative lambda, negative lambda. Here also get negative 2 lambda. Lambda, negative lambda times negative lambda will get positive lambda squared minus 1 equals 0 like that. And then when we reach at this level, we'll just solve this. So we'll add and subtract 1 from the 4. So we have the lambda squared minus 4 lambda. We are just simplifying, then plus 3 is equals to 0. When we reach at this point, we are solving a quadratic equation. So what we'll do is, this is our sum. So I'll say sum is equals to negative 4. Product is equals to 3. Product is the coefficient of lambda squared multiplied by the constant. That is product. So our P equals 3. What is our factors? Factors, these are numbers that when we add, we'll get a negative 4. When we multiply, we'll get a positive 3, which is negative 1, negative 3. When I add, I'm getting a negative 4. When I multiply, positive 3. From there, we'll say lambda squared minus, we are getting the factors lambda, then minus 3 lambda, then plus 3 is equals to 0. From here, what we are doing, we are just solving the quadratic equation. So I will love this cutoff part and continue with the quadratic equation. So at that point there, we'll say in brackets you put the first variable, so lambda minus lambda like this, then again the last two, -3 lambda minus 3, sorry, plus 3 will be equals to 0. Then at that point we'll continue. So I'm going back, then yet I'm going down, then I go up again, since the board is not enough down. So from there I'll say, just erase, I'll say we factorize lambda out, so I'll say lambda out, then I have lambda minus 1. The other side I'll say -3 out, then I have lambda, then minus 1, like this, 0. This and these are common factors, so you get one common factor, so you get lambda minus 1 should be equal to this 0. Then you say and again lambda which is outside and with the what you factor out, so this lambda here minus 3, which is 0. Then from there we say lambda equals, the one goes that side, which is 1, and also lambda 3, the 3 jumps the equal sign, the -3 becomes positive 3. So this is lambda 1 and this is lambda 2. So these lambdas, the value of lambdas, they are called eigenvalues. So we say the eigenvalues are lambda 1, which is equals to 1, and lambda 2 equals 3. Thank you for watching. Please subscribe, like and share.